When installing a 120/208 volts, 3-phase, 4-wire electrical service with multiple main disconnect switches, understanding the proper bonding procedures is critical. The National Electrical Code, or NEC, provides guidelines for ensuring a safe and reliable electrical installation. While the NEC may not explicitly require bonding the neutral to the enclosure for additional main switches beyond the first, it is strongly recommended for enhanced safety and equipment protection. Bonding the neutral to the enclosure provides a path for fault currents to return to the source, which is essential for effective ground fault protection. Without this bonding, fault currents may not have a clear path back, increasing the risk of ground faults and potentially hazardous conditions. Bonding helps to prevent the enclosure from becoming energized in the event of a fault. If a fault occurs and the enclosure is not properly bonded, it could become energized, posing a significant electrical shock hazard. Bonding provides a low impedance path for fault currents, ensuring that the overcurrent protective devices, such as circuit breakers or fuses, trip quickly to energize the circuit. Bonding can also protect the switch enclosure from damage due to voltage surges or transient events. Surges and transients can damage sensitive electrical equipment, and bonding provides a path for these disturbances to ground, minimizing their impact on the enclosure and connected equipment. To bond the neutral to the enclosure, firstly install a grounding bushing on the neutral bus bar. This bushing provides a connection point for the bonding conductor. Secondly, connect a copper conductor with a minimum size of 8 American wire gauge or AUG from the grounding bushing to the enclosure using a bonding screw or lug. Ensure the connection is secure and properly tightened. Thirdly, mark the bonded conductors as ground and neutral to distinguish them from ungrounded conductors. This marking helps prevent confusion during future maintenance or modifications. In addition to bonding the neutral to the enclosure, there are several other requirements that must be met to ensure a safe and compliant electrical installation. A grounding electrode system must be installed in accordance with the NEC to provide a low impedance path for ground fault currents. This system typically includes grounding electrodes such as ground rods, ground plates, or metal underground water pipes. The grounding electrode system must be properly sized and installed to effectively dissipate fault currents into the earth. An equipment grounding conductor must be run with the feeder conductors to provide a path for ground faults. The equipment grounding conductor connects the non-current carrying metal parts of electrical equipment, such as enclosures and raceways, to the grounding electrode system. This conductor provides a low impedance path for fault currents, ensuring that overcurrent protective devices trip quickly to de-energize the circuit. A bonding jumper must be installed between the main disconnect switch and the equipment grounding conductor. The bonding jumper provides the connection between the main disconnect switch enclosure and the equipment grounding conductor, ensuring that all metal parts are properly bonded together. This connection helps to minimize voltage differences and provide a low impedance path for fault currents. The size of the bonding jumper must be determined in accordance with the NEC, based on the size of the feeder conductors. It's essential to consult the NEC for specific requirements regarding grounding electrode systems, equipment grounding conductors, and bonding jumpers. The NEC provides detailed guidelines for ensuring that these components are properly sized and installed to provide adequate protection against electrical hazards. In a 120/208 volt system, the grounded conductor, or neutral, is typically identified by a white or grey color. This conductor is intentionally grounded at the service entrance to provide a reference point for the electrical system. The ungrounded conductors, or hot wires, are typically identified by black, red, and blue colors in a 3-phase system. These conductors carry the electrical current to the load. The equipment grounding conductor is typically identified by a green or bare color. This conductor provides a path for fault currents and is connected to the non-current carrying metal parts of electrical equipment. When working with electrical systems, it's crucial to follow all safety precautions and wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. Always de-energize the circuit before working on any electrical components, and verify that the circuit is de-energized using a voltage tester. If you are not familiar with electrical work, it's best to consult with a qualified electrician to ensure that the installation is safe and compliant with all applicable codes and regulations. Remember that electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others. Proper bonding and grounding are critical for ensuring a safe and reliable electrical installation, and it's important to understand the NEC requirements and best practices for these procedures. By following these guidelines, you can minimize the risk of electrical hazards and protect your equipment from damage. Let's delve deeper into some specific aspects of neutral bonding and grounding in a 120/208 volt system with multiple main disconnects. Firstly, the size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the service entrance conductors. For example, if the service entrance conductors are 1200 amps, the grounding electrode conductor would typically be sized at 3/0 AWG copper or 250 kc mil aluminum. Secondly, the equipment grounding conductor is sized according to NEC Table 250.122, based on the rating of the overcurrent protective device protecting the circuit. For example, if the overcurrent protective device is rated at 1200 amps, the equipment grounding conductor would typically be sized at 3/0 AWG copper or 250 kc mil aluminum. Thirdly, the bonding jumper between the main disconnect switch and the equipment grounding conductor is sized according to NEC 250.102. This section provides detailed requirements for sizing bonding jumpers based on the size of the feeder conductors. It's important to note that the NEC provides minimum requirements for bonding and grounding, and in some cases, it may be necessary to exceed these requirements to ensure adequate protection. For example, in areas with high levels of electrical noise or sensitive electronic equipment, it may be beneficial to install additional bonding conductors or use shielded cables to minimize the risk of interference. Also, consider the specific requirements of the local electrical inspector and any applicable local codes or regulations. Local jurisdictions may have additional requirements that must be met, and it's important to be aware of these requirements before starting any electrical work. When installing grounding electrodes, ensure that they are driven deep enough into the earth to make good contact with the soil. The NEC requires that grounding electrodes have a resistance to ground of 25 ohms or less. If the resistance is higher than 25 ohms, additional grounding electrodes may be required. When connecting grounding and bonding conductors, use approved connectors and methods. Avoid using methods that could damage the conductors or create a loose connection. Ensure that all connections are clean, tight, and properly insulated. Regularly inspect grounding and bonding connections to ensure that they are in good condition. Look for signs of corrosion, damage, or loose connections. If any problems are found, correct them immediately to maintain the integrity of the grounding and bonding system. It's also important to understand the difference between grounding and bonding. Grounding is the connection of the electrical system to the earth, while bonding is the connection of the non-current carrying metal parts of electrical equipment together. Grounding provides a path for fault currents to return to the source, while bonding helps to minimize voltage differences and prevent electrical shock hazards. In a 120/208 volt system, the neutral conductor is intentionally grounded at the service entrance to provide a reference point for the electrical system. This grounding helps to stabilize the voltage and prevent voltage fluctuations. The equipment grounding conductor is connected to the non-current carrying metal parts of electrical equipment to provide a path for fault currents. This conductor helps to ensure that overcurrent protective devices trip quickly to de-energize the circuit in the event of a fault. Bonding is used to connect the metal enclosures of electrical equipment such as switchgear, panel boards, and motor control centers together to create a low impedance path for fault currents. This bonding helps to minimize voltage differences and prevent electrical shock hazards. In summary, bonding the neutral to the enclosure for additional main switches in a 120/208 volt system is a recommended practice that enhances ground fault protection, safety, and equipment protection. By following the proper bonding procedures and meeting the additional requirements outlined in the NEC, you can ensure a safe and reliable electrical installation. Remember to consult the NEC and local codes for specific requirements and to always follow safety precautions when working with electrical systems. Consider a scenario where a ground fault occurs in a piece of equipment connected to one of the main disconnect switches. If the neutral is not bonded to the enclosure, the fault current may not have a clear path back to the source. This could result in a prolonged fault condition, with the equipment enclosure becoming energized. If someone were to come into contact with the energized enclosure, they could receive a serious electrical shock. However, if the neutral is properly bonded to the enclosure, the fault current will have a low impedance path back to the source. This will cause the overcurrent protective device to trip quickly, de-energizing the circuits and preventing a potential electrical shock hazard. In addition to protecting against electrical shock hazards, proper bonding and grounding can also help to protect sensitive electronic equipment from damage. Voltage surges and transient events can damage electronic equipment, and bonding and grounding provide a path for these disturbances to ground, minimizing their impact on the equipment. For example, if a lightning strike occurs near the electrical service, a voltage surge could travel through the electrical system. If the equipment is not properly bonded and grounded, the surge could damage sensitive electronic components. However, if the equipment is properly bonded and grounded, the surge will be diverted to ground, protecting the equipment from damage. In conclusion, while the NEC may not explicitly require bonding the neutral to the enclosure for additional main switches, it is a recommended practice that provides significant benefits in terms of safety and equipment protection. By following the proper bonding procedures and meeting the additional requirements outlined in the NEC, you can ensure a safe and reliable electrical installation. Always consult the NEC and local codes for specific requirements and to always follow safety precautions when working with electrical systems. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Proper bonding and grounding are critical for ensuring a safe and reliable electrical installation, and it's important to understand the NEC requirements and best practices for these procedures. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before starting any electrical work. Let's also consider the importance of using the correct types of connectors and hardware when making grounding and bonding connections. Using the wrong types of connectors can lead to loose connections, corrosion, and increased resistance, which can compromise the effectiveness of the grounding and bonding system. For example, when connecting a grounding electrode conductor to a ground rod, use a listed and labeled grounding clamp that is specifically designed for that purpose. Avoid using generic clamps or connectors that are not designed for grounding applications. Similarly, when connecting bonding jumpers to metal enclosures, use listed and labeled bonding lugs that are designed to provide a secure and low-resistance connection. Ensure that the bonding lugs are properly tightened and that the surfaces are clean and free of corrosion. When making connections to aluminum enclosures, use connectors that are specifically designed for use with aluminum. Aluminum is more susceptible to corrosion than copper, and using the wrong types of connectors can lead to corrosion and increased resistance. Use antioxidant compounds to prevent corrosion when connecting to similar metals, such as copper and aluminum. These compounds help to prevent the formation of oxides that can increase resistance and compromise the connection. Regularly inspect connectors and hardware for signs of corrosion, damage, or looseness. If any problems are found, replace the connectors and hardware immediately to maintain the integrity of the grounding and bonding system. Furthermore, the NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all. This listing ensures that the equipment has been tested and meets certain safety standards. When selecting electrical equipment, always choose equipment that is listed and labeled by a recognized testing laboratory. This will help to ensure that the equipment is safe and reliable. Also, consider the environmental conditions in which the equipment will be installed. If the equipment will be exposed to moisture, corrosive chemicals, or extreme temperatures, choose equipment that is designed to withstand those conditions. For example, Use enclosures that are rated for outdoor use in wet locations. Use conductors that are insulated with materials that are resistant to moisture and chemicals. Use hardware that is made of corrosion-resistant materials. In addition to following the NEC requirements, it's also important to follow industry best practices for grounding and bonding. These best practices can help to improve the performance and reliability of the grounding and bonding system. For example, use a star grounding configuration whenever possible. In a star grounding configuration, all grounding conductors are connected to a common grounding point. This helps to minimize ground loops and reduce the risk of electrical noise. Use separate grounding conductors for sensitive electronic equipment. This helps to prevent electrical noise from interfering with the operation of the equipment. Use shielded cables for sensitive electronic equipment. Shielded cables help to block electrical noise and prevent it from interfering with the operation of the equipment. Conduct regular inspections and testing of the grounding and bonding system. This helps to identify and correct any problems before they can lead to safety hazards or equipment damage. Use a ground resistance tester to measure the resistance of the grounding electrode system. The resistance should be 25 ohms or less. Use a continuity tester to verify the continuity of the grounding and bonding conductors. The continuity should be low, indicating a good connection. By following these industry best practices, you can improve the performance and reliability of the grounding and bonding system and ensure a safe and reliable electrical installation. Remember that grounding and bonding are critical for protecting people and equipment from electrical hazards. It's important to take these procedures seriously and to follow all applicable codes and regulations.